Hey everybody, my name's Sean and this is Science Hunters, where we at VML Health talk about recent science that's come out that we think is super interesting, that we think can affect medicine, health in general, going forward. And today what I want to talk to you about is what I think is one of the coolest frontiers in all of biology and in all of medicine, and that is the brain. Now, I'm a molecular biologist, so I think of questions like, how do we store memory? How do we control thoughts? How do we control behavior on a molecular level? These are all super fascinating questions that many, many people around the globe are looking at and exploring. And today I'm going to talk about a specific study from a group in UCLA that came out in the last month. So when you think about the brain, you're probably thinking about the millions and millions of neurons that make up the brain. Right? Those are the things that we think are controlling our thoughts, are controlling our behaviors, are controlling the way we react to certain things. And for the most part, that's probably true. But there are a number of other types of cells in the brain that are not neurons, support cells, cells that are making sure the neurons have the nutrients and the oxygen that they need to make sure that the neurons are working properly, that they're conducting impulses between each other very efficiently. And it's those support cells that we learned something about from this UCLA study. Specifically, I want to talk about a support cell that's called astrocytes. Astrocytes are these really cool looking cells. They look like really spindly starfish. They've got projections that wrap around other neurons and such. And what's really interesting about astrocytes is that astrocytes from one part of the brain are slightly different than astrocytes from other parts of the brain. They express slightly different gene profiles. And scientists have understood this for some time, but they never really understood what the relevance of it was. And so this study looks specifically at a population of astrocytes in the central part of the brain, something called the central striatum. Okay, and they created mice that they deleted one specific gene in that specific population of astrocytes. All the other cells in the brain have all the genes that a normal mice has, but we deleted one specific gene in those central astrocytes. That gene is called CRIM. It's a gene that has been implicated in a number of different sort of neuropathologies in humans. So that was part of the reason why we're looking at it. But again, we're looking very specifically at that region. And what scientists found is when they delete CRIM, okay, they get a behavior, a repetitive behavior out of mice, okay? Perseverance is what it's called. It's this repeating behavior, okay? And it is highly characteristic of neuropathologies that have been identified in humans that have CRIM mutations. Things like Tourette's syndrome, things like OCD, okay? Things like Huntington's disease. All of these are known for those repetitive behaviors that these mice are now manifesting because of a loss of a gene in astrocytes, not in neurons. So this is fascinating. It's fascinating for two different reasons. One, we now have a whole new set of cells that we can target with medicines that may help some of those neuropathologies. But more importantly, it is direct evidence that behaviors, neurobehaviors, is not just guided by neurons. It's a little bit of a dogma shift in how we think of those things. Astrocytes can directly influence behavior, not just your neurons. And from a basic biology standpoint, that is also fascinating. So I think this study is great. I was kind of blown away from it. Again, I am an immunologist by training, so to see really cool stuff in other fields just really blew my mind. I hope you guys appreciate it as much as I did. We'll be back with other cool science in the next time. Till then, science rules. Thanks, everybody. Bye.